Okay, so hi everyone. Today I broke the talk into three components. Act one is about why it's important to um, kind of integrate rapid prototyping in your development process. Number two, Act two is going to be about how Whiteboard does it, specifically some of the methodology, the tools, and the thought process that we have in deploying our data science team to build applications. And the number three is going to be kind of what are the things we built and a little bit about the future of work. I know that there's this, this conference has been is very forward-looking, and I do want to kind of jump into the dialogue a little bit about what we think the future of work could look like with data science, specifically in the enterprise the context. So just a little bit about Whitewell. We are a small data science company that's solving some pretty big problems with DeepSea. Our mission is to elevate human creativity and collaboration at a large scale. We're doing so through data science, and our portfolio includes energy, real estate, community, and pro sports. So these are some of the work that we've done in the Alberta in the ecosystem. This is a triangle. Triangle is one of the most robust, stable structures, and it actually highlights about we build a lot of things with triangles, and there are three ways in which you can build something, whether that's building a house, building a team, building a product or project. It's underpinned by these three dimensions. So the society and the economics almost want to have all three. You can build something fast. You can build something really quickly in a short period of time, right? You can build something that's really big, or you can build something that's really long, or something that's built to last. So the society does want you to have all three, but Whiteboard has a theory that you can at most focus on two of them at any given point. And so when it comes to building projects or product, this is where the first kind of step is to decide where you are in this triangle. We have a theory that for Whitewell, we chose to build things for the long term and to build it big, which means we're not very fast. So the only thing we're fast at failing, failing really, really quickly in our projects. So it took us 7 years to get to where we are. So we're going to be sharing some of those lessons and that we've learned, picked up over the years. So today we're actually going to be a proponent when it comes to data science to go fast and go big. So why not go long? Well, the answer is that a lot of organizations can't afford to go long because there's too much uncertainty, right? So by the time you finish building that application, the world has changed, which means there's too much risk to take on. To plan for that super long term when everything's happening in the short term and happening really, really quickly. So that means you want to go fast. And you also want to go big because without scale, without size, your data science project isn't going to make the impact that it could have. And without that impact, it's really easy when it comes to the rate of return, it just gets killed and never goes anywhere. So even if you have really good ideas of applications for data science, if there's not a path forward to scale on a large scale, there's not enough ROI in order to continue the project. So then how do we make data science project go big and go fast at the same time, right? So to answer that question, we almost have to look at, well, what makes it the opposite? So what makes it slow and what makes it small? So being a big sports fan, this is one of my favorite moments. This is like, for those who don't have the full context, this is the Eliud Kipchoge, the first human to run a marathon in sub 2 hours, under 2 hours. This is like our, in our lifetime, is similar to the sub 4 minute mile, which nobody thought was possible. But so this obviously happened a couple of years ago. And how did this happen? Well, you see in this picture, Iliad's crossing the finish line in less than 2 hours, but there's actually a lot more going on behind the scenes, right? And what are those things? Well, you have the perfect weather running condition. It's not too hot, too cold. You have smooth, you have flat surface with traction. You also see these pacers in the background, right? Kind of blocking, sheltering the runner so that there's minimum wind resistance. You also have the crowd that's energizing him throughout the race. And then you have the kind of all the support, from the carbon plated shoes to the sports scientists, the coaches working with them. So these are all the pieces that go into what makes a sub-2 marathon possible. And at the end of the day, you also need a superstar to be able to actually run. So if you put me in that race, I will not be able to run sub 2 hours, even with all the help, all the perfect conditions, all the carbon fiber plated shoes. That's not going to happen. So you need a superstar. So what is a superstar in your data science application? And there's only, the data isn't going to process itself, right? It's one of those things where the wait and see strategy doesn't really do anything, because if you don't do anything with your data, the data is not going to do anything for you. So what is then the superstar of your data science application? And it has to be your algorithm. So let's take a look at this thing. So this is the piece that your data science team is focused on. And assuming you have the right algorithms, then what, right? In order for the superstar to shine, we see that you have a supporting cast. And similarly for your algorithm, it also needs that supporting cast. So take this example. So this is a hello world example for, let's say, your algorithm, right? It's 3 lines of code. You put in the name of a string, and the algorithm is going to retain to return hello plus your name, right? So how do we actually get this running in production? So in order to get this running in production, there's actually a lot of things to slow it down, right? So let's go from the left to the right side. So first, you have the infrastructure cost. You have to set up the servers. You have the databases. You have all sorts of integrations, network, security to set up. And that's just getting the project started in a data science application. And then you have the software development costs. So that's the front end, that's the back end, that's the database, the user interface, and all sorts of testing that goes around the process of software development. And once that's in place, you have DevOps. You have to take the application, you have to deploy it to the cloud. You set up your continuous integration, continuous improvement, and continuous delivery. All of that automating at a scale that costs a lot of time, that costs a lot of money. And then on top of it, in order for it to be an enterprise application, you assume you're not going to let the project live in the public domain. You'll have to be setting up user management, user accounts, user permissions. All of those are in the way of deploying a data science application. And then on top of everything, you have the overhead. You have the added overhead of managing data, a software development team. And this is where I think the roles and the task becomes very complicated. You have machine learning, not just data scientists. I'm hearing these terms called machine learning developers these days, ML ops, right? Even though a lot of this, all it does is to support your superstar, which is your algo, to try to get it to work in production. So looking at all those things that slow down your data science project is the way to make it go faster and to go on to scale. So why is it important then? What is the next step after you have your everything set up? Well, the best way to, before you commit everything to building this project, this massive enterprise data science application, the one critical step before that is actually to validate that hypothesis before you mobilize your software team. And how do you actually do that though? You have this algorithm that's supposed to solve a business problem. How do you validate that? In our experience, it's actually pretty simple. You ask your business users, right? And the reason you ask your business users is that they're the ones who's going to understand what the use cases are and understand the objectives to be able to verify that the algorithm is doing what's supposed to do and actually delivering value to the frontline staff or the management or somewhere in between where it's actually solving a business problem, delivering business value. And to do that, you have to get the application to the hands of those business users as quickly as possible, which means we have to prototype quickly so that you can get something out to them before it's too late. Before you commit that mammoth of resources into building all the infrastructure, all the support, backend, front end, DevOps resources to building that application, you will want to actually validate the solutions. So how do we do it? And how do we do this at Whitewell? I think this is something that over the years we came to realize is that there's a lot of pieces that's on that chart that's kind of reused. So before we had DeepSea, we spent a lot of time rebuilding databases, rebuilding that front end, back end, and solving all those problems repeatedly. So we thought, well, would it be a crazy idea to think that there could be a way to automate all of those pieces, reuse them, and develop this platform such that all we can care about, all we can really focus on are the most important pieces, right? So that was our theory. That was our theory. So we spent the last 7 years building that. So what we end up with is this platform called DeepSea. And DeepSea, what it is turns your data science, turns your Python functions into scalable enterprise-grade data science applications via drag and drop. And what does that allow you to do? So that you can focus on developing and improving the algorithms. You can ship those products and solutions to the hands of business users really, really quickly. And that helps to speed up the iteration of validating your data science application as well as making improvements before companies actually commit massive amount of resources into building them. So it comes back down to this piece, this hello world, right? If we can do this for a hello world example, we can possibly scale it out. So what does it look like? So to take this code into a production environment, the way we structure the platform is to be able to take this code without modification and ship it directly into a cloud environment, and then build with all of the supporting and infrastructure around it in place. So what does the user do? What does it look like from the data scientist? Well, we know that a data scientist is not necessarily a software developer. Different skill sets, different tools, different ways of thinking, different methodologies of solving problems. So for a data scientist, after focusing all of the effort and attention to building the algorithm, the data scientist simply has to do things via the UI. So our approach is to you take this piece of code, which is hello world, and you take the folder, the directory that it's sitting in, and you compress it. So in this directory here, we have a demo.py. We have some package ABC, which is then imported into the demo.py file. And then you have some requirements.txt. So in a Python environment, this is where you declare your packages, your version numbers, and various dependencies that your code is going to utilize. So at this point, you have this local folder, and you compress it into a zip. And once you have the zip, you upload this into DeepSea, and it's called test package. In this case, you give it a name, and DeepSea is going to figure out all of the files, the contents, as well as all the functions within it, and ask you which one do you want to turn into an application. So in this case, we are choosing to go with the hello world function and turning that into an application. And then on the other side of it are the business users. So the business users interacts with the data app through these simple inputs, and everything you're seeing here is built through drag and drop, right? So we started with this idea that data scientists should just focus on the algorithm, and everything else can be taken care of through drag and drop by making it easy to build these interfaces, doing software without code. That's kind of the vision and the ideas. So how does that actually work behind the scenes? How do we use this to do rapid prototyping at Whitewell? So once this is kind of configured and set up, we are opening up the hood of how does this actually work. So you have an interface, you have an input. In this case, it's just asking for a name, a string input, and you have a button called run. This run button just executes the model. And what it does behind the scenes is that it takes the input, which is the Mobi, the text string from the front end, and then it sends it into the Python function, which is looking for a variable, a parameter called name, and it's going to return a string that's concatenated of hello plus name, right? Hello Moby in this case. So it's going to output this hello Moby as a string and put it into a built-in database. Again, so because all these pieces are reused, we have a database set up so that we can reuse and not having to, come up with new ways of managing and storing the outputs, right? And once a task is complete, the database on the backend informs the front end, the dashboard, to refresh and update itself. So it becomes an interactive dashboard. I can't see any faces, so I don't know if these ideas are making sense to people. If you could put it in the chat, that'd be great. So I know to either dive in a little deeper or not. Okay. So where was I? Okay. So this is a very simple example of putting in hello world. It's a hello world example of building an application through a function. What are some of the other things that we can do? So this is where, in the last few years when we are working with this platform, we discovered a lot of different use cases with our users. And this is the part where shipping your product to the end user becomes tremendously valuable, because having that feedback could help you understand where to go from there. What are the important features? What are important requirements that solve the business problem? So the next slide are we're going to look at a few examples that's been deployed and operate on DeepSea. And again, we built all of these with our users, with our customers. So this first one is the Stats Canada demographics. Almost every single one of our community clients are currently using this. The reason is because it delivers such rich fundamental information that help the organizations in the community, social enterprises, make good data-driven decisions. And it's in interacting with them, getting the feedback, we know what are all the metrics. So Stats Canada has a huge database. They collect tons of data. And by talking to their customers, we actually understood what are the most important metrics that they care about that we should visualize. So the way this application works is you type in the postal code, the first 3 digits of the postal code, and DeepSea is going to return all of the most relevant information back onto a dashboard. Instead of saving and caching all the database and having scheduled jobs to maintain it, this is just calling a live API at Stats Canada. This means we don't have databases to maintain. We can grab the latest data whenever they become available, and that helps us deliver these analytics insights to our customers really, really quickly. So the second one, this was a dashboard that was built during the Olympics. It keeps tracks of all the different medals and the competitions and all the different results. There are different tabs at the bottom where you can see various competitions, and especially the Team Canada. Again, this is something that we feel if you're able to do these kind of quick prototyping, your product becomes meaningful in conversation with what's going on in the world, right? So to do this quickly, it's tremendously important, because often at times you don't have the time to fully react to what's happening. By the time the Olympic Games finished, you may have, if you aren't able to release a product before that, between the day 1 and day 16 of the games, it's kind of, you lose out on that relevancy in the industry, in the community. This is a F1 dashboard. We have one for 2022. I think there's a race this weekend, which is exciting to check out. So if you are participating in some sort of F1 fantasy pool, do check it out. This one is a public dashboard. You are able to see all the results, all the details, all the pit stops, every single race for the last season, and be able to make smart data-driven decisions on who you should pick and acquire for your fantasy F1 team. So again, these are the things that we're building for fun, just to help with creating that dialogue and discourse in the community. We have a couple more examples. This is one that actually, so this started as a Fun Friday idea. We're looking at, can we use AI? Can we use algorithms to process movies based on the scripts, figure out the character interactions, and figure out the main characters and generally what's happening in the movie. So this was developed over a couple Fridays, and we released it to DeepSea in preparation for the Oscars, to see, what are the movies about, because we can't watch every single movie ever. But and then last Friday, this actually just happened. Someone from our team added a couple more APIs, and you can see how quickly and easily it is to tweak these things. So Terminator is my favorite movie, with the keeping the context of AI and machine learning. This is something that after we add a couple of KPIs, you can build something like this in DeepSea really quickly. So this was done yesterday. Someone from the team just took the code, added a few lines, added a few API calls, and we have added descriptions and synopsis, the covers, and the main actors. So again, these are the quick, fun stuff you can do. Here we have NHL. So I do spend a lot of time in the rink. So here we have an NHL dashboard that's keeping track of the results of processing 2 billion data points. So the computer actually has a perfect memory of every single game, every single shift, every single shot. And these are the things that you can build in real time to deploy to capture the essence of what's going on a game. And then as well, we have solutions deployed in energy space. So this is a production forecasting model on DeepSea, 4,000 wells, 40 years of forecast in 4 minutes, and it has freakishly good accuracy. Again, the point of all of these is to demonstrate that the importance of being able to prototype these quickly so that you can build many applications with many business and stakeholders at the same time, when you're able to have the fast feedback and iterations to continuously improve, and by focusing your energy on the right problems and right applications. So this last one, I won't get into it.
Peter, I'm wondering if you want to take some questions on the fly, or if you prefer to have them at the end there.
I can take someone after. Yeah, I can take some questions after this one. It's okay. Last example, optimizations in SAGD, probably one of the more complicated problems we solved. Again, with that focus we have in the data science team, we're using it to optimize fuel level productions and do so in a very quick manner.
Cool. Okay. Well, maybe actually this one is relevant. So dealing with hundreds of millions of rows of data, like I see you've got there 100 million data points, 100,000 scenarios. Maybe this one is talking about the scalability of the DeepSea platform. Maybe you can touch on that.
Yeah, for sure. So code that deals with 100+ million depends on what it is, right? So any NHL example, we process 2 billion data points just to isolate the shots and the important metrics. So if it's a matter of you can take chunks of that data, one chunk at a time, then you can do so at a game-to-game basis. So with the compute power that we have today, with all the platforms that offer, it's just a matter of time. And when you can parallelize those processes, it makes things much quicker. So that's how we process 2 billion data points from NHL. It's breaking into chunks, do them in parallel, and have the most relevant results dumped into another data set that's ready for machine learning. I think that's a very typical setup for machine learning and data science applications. Good question, though.
Great. Oops, wrong one. So now you know that there was a qualifier this weekend.
Yeah.
What is the downside, or watchouts or pitfalls to be aware of for rapid prototyping?
I think the whole point of rapid prototyping is to be able to fail quickly. You want to be able to find flaws and weaknesses in the solution so that you can address them. So the downside is actually not getting enough feedback quickly enough early on, such that you're on this path that actually doesn't end up delivering any actual business problems. So make sure that you have that line of communication really open, and you do that by quick iterations and engaging with the business users.
Awesome. Okay, thanks for that, Peter. Why don't you continue on, and then I'll keep looking for questions to
Cool.
get to you. Yeah.
So yeah, so the point of all of that isn't kind of to show what the solutions actually do, but to show what you can build with very small team and very small amount of resources in a short period of time, by changing the way you approach data science applications and data science problems. Right. So back in 2015, before we started this journey that we needed something like a DeepSea, we were pretty good. We were small, nimble. So at the top, this top line is a typical way of building data science applications. So you start with about 3 weeks of paper solution. That's just talking to all the stakeholders and business users. You kind of try to solve the problem on paper. If we had this data, if we build a model that can predict this with this amount of accuracy, and it has these results, can you act on it? Can you make use of that data and insights? And so that's what we do kind of to start the project, is some sort of paper solution to figure out what is the business problem and where's the value add. And then the last week of that, week number 3, is to getting some code to have some sort of early prototype, to be able to kind of get an idea across with some maybe outputs from in an Excel spreadsheet or a CSV. Maybe build a few graphs in Matplotlib, or if you're using R, like ggplot2, which is what we used in the past. Once kind of all that's kind of validated and kind of in place, we then start building that backend system for the application, and simultaneously start on the front end of the design on the dashboard side to think about the user experience. And then at some point around week number 6, we have to rewrite that data science code, right? Just because the code itself has to live in somewhere else, and there's some tweaks and changes that you have to make it compatible with the bigger software application. So that's kind of the process we used to have, and then that will take anywhere from, let's say, 6, 8, 10 weeks, and then at some point you're going to deploy the version 1 of this prototype into a production environment so that you can hand this off to the users for some early feedback. And typically within that first couple of weeks, you have changes to make on the algorithm, and then you have more things to tweak after that. So anytime between basically anywhere from week number 4 to week number 10, your data science, your algorithm doesn't really change much. And the reason it doesn't change much is because you don't know if it's actually working. You don't know how it does in the field. All you have is this kind of sandbox environment to test and play with, but you don't really know how it's going to do in the field. So the sooner you can shorten that week 4 to week 11, that's where all the cost saving, that time saving becomes. And while you have the momentum to really drive the feedback loops with a business user to make these improvements. So what we used to do back in 2015 is around that week 12 mark, things start to settle, and we start to collect data. We started to look at what are the outcomes and things we can improve on, and then make more changes on week 14 and 15. Again, this is what our approach was back in 2015, and even by today's standards, I think one application within 4 months, it's still pretty quick. Um, but what we found was that even at that speed, we don't really have the scale. We have the fast. We chose to go fast in 4 months, but what we end up giving up is the scale, because we can't really maintain it. We can't really take on multiple projects of the sort, and to be able to continuously improve them, because every time you have a code change, you almost have to go back to all the other pieces that your superstar, your algorithms touching. So that's the front end, the back end, the user interface, all the testing and the deployment, all of that have to be reworked, and then it becomes a nightmare to manage. So that's when we decided, what, we gotta figure out a different way. And so our new approach with DeepSea, you can see kind of the schematics at the bottom. So Whiteboard with DeepSea, you kind of still have the first 3 weeks of paper solution. That's just science. That's just solving the problem without worrying about code, right? You want to solve the problem fundamentally, what it looks like. That part stays the same. The coding part, week number 3, stays the same. But what happens differently next is the gap between week number 4 to week 11, or week 9 in the above diagram, is we can go directly to production with a piece of code. Once we push that code into this data science team, kind of wrap up the the core algorithm, you then push it to production so that you can get user feedback immediately. So rather than losing any momentum at this point, at week number 4, our clients are the end user, the business users are already using the applications to give feedback and give their thoughts on how the UI should look, what are some of the additional functionalities and all that. Unfortunately, a lot of times in our experience is that you don't really know what you don't have until you see what you do have, and then to create these add-ons. So that's where things get really interesting for us, because by showing this week 4 to week 10, we're able to capture that momentum and then push out 2 more releases in a similar amount of time where we would deploy the first application. So by version number 3, a lot of the kinks, a lot of the the bigger issues have been resolved. So at that point, the business unit could sit down and look at this in a more comprehensive way. Is this something that's worthwhile to continue? If not, what are the things that we need to address? And if so, what are the elements that could make it 5% better? What are the ways to push it out to more users and owner groups to deliver that data science value?
This looks like it would be a great tool to use to get buy-in from leadership. So there's a comment that came in from Nestor just about this would be great for stage gate processes. Just curious, Peter, if you've seen that by taking this rapid prototyping approach, has that helped leadership become a little bit more sympathetic to machine learning projects that are being pitched to them?
Absolutely. I think anytime when you start a project, it's really exciting, and you have your objectives, your different groups. I'm going to talk about the team side of things in the last section, but basically you have a lot of energy at the beginning, right? And this is where, if you're able to show those early results, get people excited, you get the buy-in, and you get people kind of subscribed to this project, to want to keep up, to know what's going on. You get you get more engagement and more conversations about it, which actually increases the probability of success, because they have been involved early on and they've seen it being developed from the very beginning. And that's something that when we look back on some of the projects we did over the years, just to be part of those projects, I think is a tremendous experience for people. In the last few years, people shift jobs and they go to different places. But when we catch up with those people we used to spend a lot of time with, they always recall the time that's of building these data science projects. It's a lot of fun. Okay. Okay, cool. So let's jump back to my slides. Okay, so the last section of the talk, before we get into all the Q&As, is it's really about team and what happens next, right? So what? So what we have tools today. What are some of the elements that you can do without DeepSea, with or without DeepSea, that kind of prepares you for this these changes in the future of work in data science. So one of the things is, I'm going to start with a couple of the trends we notice in the industries, especially in the last couple of years, given the amount of changes. The number one trend is this shift, this change in the workforce. We're seeing things to become very adaptive, diversified, and distributed. And what that means is we're no longer relying on kind of the same structure where you have an office or a team that does one thing and only that one thing, and that's kind of what they do for the company. We're seeing people being pulled from all different places. You have the combination of full-time employees with consultants, with freelance workers, with data scientists, with interns, with students, community groups, all joining forces to tackle one of these data science problems. So that's where the first change we're seeing is just the diversity and distribution and adaptiveness of that workforce. So finding ways to take advantage of that in your data science applications would be will be a huge plus if you can figure that out. The second thing is a lot of these applications and different work groups now are more project-based rather than role-based. So what do I mean by that? So you can have the best data scientists in image processing, let's say, but that person may not be very helpful to do pricing analytics for an airline, for example, right? So because different projects have different needs and different requirements, it makes it pretty difficult to select from a pool of roles that's in-house today, which means there's going to be a lot more of tapping into resources and talents that may be outside of your organization, that may be coming from the freelancers or the consulting world, where you can take that expertise and slot it right into your project with clear definitions of what the requirements are and how you measure success. So that's the number two trend we're seeing is having things being project-based, not role-based, when it comes to assembling the right team to build the enterprise applications. And the third thing that's going to force in that we're seeing in the market is being in a highly collaborative environment. So I think there's a lot of kind of ideas and talks about collaborate, but collaboration goes beyond kind of the team and culture. It also goes beyond goes into the tools and the kind of the collaboration on an even larger scale. So one of the things that a lot of projects that I'm seeing these days in our involvement is that they're kind of restricted by the tech stack that they're using. That kind of prevents them from being able to do things in a way that's getting the best of what the community has to offer. So, for example, a lot of the software, if you're subscribing to specific platform machine learning services providers, let's say, you kind of don't have the full capabilities and ability to tap into the open source community, for example, right? You're limited to using certain packages or certain tech stack in building these applications. So in order to have that that move at a great speed, the technology stack has to be fitting with the things that you're working on. So one of the way we envision how the future would be is that you would have this world where you have data that's going to data scientists who's going to create algorithms and going back to business users who's then generating more data for the data scientists. So there's nothing in this kind of diagram that suggests that all of this has to be living in a single enterprise or a single corporation. So because of that, I think there's going to be a lot more freelancing data scientists, freelancing consultants, who's really good at certain topics, right? Like the data scientist who's just an expert in machine learning for image processing, and an expert who's really good at pricing analytics or NLP. They all have different domains that they're really good at. And it is up to the business users and the companies of tomorrow to figure out how to assemble that ideal superstar team and then be able to focus on the right problem, to push out the data, to push out the solutions to the end users and getting that feedback quickly to build the next generation of data science apps.
Which I think is a good point. There's just been some just chat in the comment box about, well, like, what is DeepSea? Some folks are used to using corporate tools like Power BI, Tableau, which are starting to acquire more functionality to utilize languages. So, and then further discussions that DeepSea's like an IDE, integrated development environment, almost like a bit of a sandbox by which you can deploy some code, have it do its thing before it actually goes into full-blown production.
That's right. So DeepSea turns your Python functions into a scalable enterprise-grade data science application. I don't think Power BI or Tableau turns your Python functions into production-grade applications. Oh, sorry, I just got one more. So is it more like Azure ML? I never used Azure ML, so I'm not too sure. I think the idea is that a data scientist in your IDE environment, your local development environment, whatever solutions you're working in, whatever package dependency, how you want to build the algorithm, that same thing is going to be containerized and carried over to DeepSea, and it will work the same way as you would locally, but at a scale. Good question. Unfortunately, I just don't know enough about Azure ML. Just checking in on the comments. Any other questions?
Yeah, looks like we're pretty good right now at this point, Peter.
Awesome. Yeah, I think that's pretty much all the ideas I wanted to share with you guys today. If there are, people want to get in contact, and whether that's with DeepSea or not, I think there's a lot that we can talk about in terms of, the examples of project and how we can leverage the public data sets in an ecosystem where enables data scientists to create their portfolios and deploy their algorithms in a way that benefits the users, business users, without having to give up all of their IP.
We do have a couple more questions that have just come in. And it's I think one of those things, like as soon as you start wrapping up and people go, oh, wait, I've got one more question. So this one I'll put up. Is it both infrastructure and code to go to big scale?
It's the infrastructure. Is it both infrastructure and code to go to the same scale? It can be, depends on how you set it up. So for us, giving an example in the oil and gas industries where we're taking data from SCADA, we're pretty much deploying all these little pieces of the code that does one thing to process the data and then store it somewhere in the data lake. So for your code to scale, locally, you would have, I don't know, the most you can do is number of CPUs you have in your computer. But in the cloud, what you can do is have multiple workers to run the same code, right? So that's where we're scaling that code across multiple instances of compute engines to do their task, like worker nodes. This way, you don't have to write code to say, hey, I want to run parallel processing. I want to do this, join the results. That's all taken care of for you. And the other question is on how you manage data pipelines. Okay, that's a really good question. So obviously you can't run a lot of things completely in memory, right? That's a limitation of memory, and I do think that the compute hardware is going to get more powerful, cheaper, more powerful, faster over time. But these are the limitations that you have anyways, if you're going to be using Python functions to solve them. So there are a few ways that we do them today. One is you have some sort of data lake that acts as a data source that's ready for machine learning. A lot of times when it comes to massive amount of data, what doesn't make it ready is the size, and not just because of the size, but it's irrelevant. It has a lot of data points that's not really applicable to the problem you're trying to solve. So the first step is actually just condensing it in a way that's applicable for machine learning, and usually that's a lot smaller than anticipated. At least in our experiences, most of the time that's not really once you condense everything, it doesn't really become, that size doesn't really become a factor.
So just maybe a clarification on that question.
Okay.
So specifically, when you cannot partition data sets, since you need to run it in real time, and when you need the results right away.
Yeah, DeepSea is not meant to solve these problems. You have things like Databricks, which DeepSea integrates nicely with. You have Snowflake. You have all sorts of things that deal with these kind of high volume, high variety, high velocity data that's coming to a system. There are other systems that deal with that. What DeepSea does is it takes the end of what you need for machine learning, the code that actually goes into a machine learning model, and then help you deploy those. So those are the problems I think you have to solve regardless of what system you use. And there are pretty nice platforms and other services that do that, which integrates nicely with DeepSea through Python functions. We have a question from Shirley.
Yeah, maybe Shirley, if you've got a question, if you want to type it in there, and then maybe while she does that, so you had shown early in your presentation, Peter, just some applications or uses of this, tracking the Olympic results, helping you out for your fantasy pools, movie analyzers. It's kind of leading us almost to where you're empowering citizens to be able to use the data. I'll avoid the use of the term data citizen because there's someone on a panel earlier this morning that had some strong sentiments against the term data citizens, but more talking about everyday folks like us, citizens, who can use data. So do you have any suggestions on how we are able to use DeepSea for our own personal uses, as opposed to just like in a corporate setting?
Yeah, for sure. And that's the ultimate vision of White Whale, right? To elevate that creativity and collaboration on a large scale. Part of that, we weren't part of that conversation, unfortunately. I think there is tremendous value for people to talk about what's going on in the community by looking at data when they have access to data. So a few things that I think are really good places to start. One is with the municipality, actual community, like City of Calgary. A lot of open data sets. A lot of times it's that the data is there, just they're not very accessible, or it's stored in a format that's not very easily usable for various conversations. So recently we have this discussion in my community about parking. Well, to do that, we kind of have to look at the data to see how many vehicles. Is it true that young people between age 20 and 35, the millennials, Gen Z, don't like to drive? They don't own cars. What are some of the data points that we can get to have a deeper, more meaningful conversations about it? So this is where I think building applications for yourself for your own interests is a good starting point, because when you are actively engaged in answering or thinking about the questions we have, it challenges you to think about things a little more critically, and sharing that results with the community, it just has a ripple effect of benefiting everybody.
Right. Yeah. No, that's a great mindset shift, for sure. Even yesterday, there was a panel conversation about the future of the data economy for Alberta. And a lot of that was really just inspiring us to think about how we can better engage as citizens who have entitlement to data to come up with these insights.
Yeah.
But sometimes the challenge is, there are a lot of publicly available data sets, but they're not very usable.
Right. And I think, as I mentioned earlier, data isn't going to process itself. It requires an algorithm to do that. And it takes creative thinking to be able to design those algorithms in a way that answers a question. I think with one of the bets we made on, and I think the rest of the data science community, it kind of it's kind of unfolding now, is this bet on Python. I think it's a matter of time that Python is going to be a language that people use just like English, writing skills, to be able to build this way of processing data and information very systematically using a computer. So that's kind of our bet too, is that when the society is at a stage where everybody can think in terms of code, or have the ability to deploy a piece of code, that's where we can get a lot of these pretty niche models in the community to do these kind of things and generating conversations.
Right. Yeah. Maybe one last question, and then we'll wrap up here. You talked about Fun Friday. That's something that is done at White Whale. A big part of actually changing the mindset is a data culture, and this sounds like this kind of bodes really nicely, feeds into a very healthy data culture at White Whale. Can you tell us a bit more about Fun Fridays?
Yeah, I think this goes to any profession. When you're just doing the same tasks, if you're always doing the same things you're doing, you don't really do anything new. And what we want to do is to force people to think outside of the day-to-day stuff. And usually those ideas are related to what's going on around us. So I guess I'm like a late boomer to the whole F1 thing that took off with Netflix a few years ago. And that's one of the things, that generated conversation. People watched it. Some people really got into it. And then we were like, well, from Friday, we're just going to scrape all the data from F1, which they did a really good job of making that data public. And out came a dashboard, and now we have a fantasy pool going, and we're just checking the data to make our roster decisions. I think anytime you can relate the work you do in a fun way to the community, I think it's just a lot of fun. And certainly we have some pretty good ideas and amazing project that came out of just those Fridays.